Let's start by doing some thinking about rational exponents. As we'll recall from previous learning, if we can develop ideas ourselves and explore them, then our retention of that information is going to be that much greater. Let's start by using a calculator to evaluate the exponents list, the powers listed there. If you're going to use your calculator, you'll enter the base of your power, and then you'll either enter this little hat key or a y to the x key. Depending on what your calculator structure is, it will be different. To enter the fractional exponent, remember to use a bracket, then write in the fraction, close bracket, equals. If you forget to put in the brackets, you will not be applying this fractional exponent properly. The first answer that you should get when you evaluate 36 to the exponent 1 over 2 is 6. I'll leave you a few moments now to work out the other powers. So let's take these up. 25 to the exponent 1/2 is 5. 4 to the exponent 1/2, 2. And let's fill in the other values all the way down the list. It may be that you noticed right away that the numbers that were the base of each of these powers were very familiar to you because they are the perfect squares that we discussed when we tried to simplify radicals. So we could see that if we wanted to, we might be able to write these powers out a little bit differently. We might be able to write this as the square root of 36. Notice that's giving us 6. The square root of 25 is equal to 5, all the way down to the square root of 81 being equal to 9. So hopefully we can notice that if we wanted to take away some information, that if I had anything, I don't really care what the number is, but if I'm raising it to the 1/2, I could simply evaluate that by taking the square root of that particular number. Let's move forward and see if we can extend our thinking a little bit. I want you to copy down the questions below, use your calculator to evaluate each of the powers, and see if you can make some further connections. Let's see what we notice here. I started with 5 cubed, and I evaluated that, and that is 125. Let's see if there's anything else in the list of calculations here that comes close to that or connects to that. So I noticed that there's the number 125 over here, and it's got the exponent 1 over 3, and that's telling us the answer is 5 from our calculator. Let's pop down to 2 cubed. So that's 2 times 2 is 4 times 2 is 8. My calculator can give me that answer, but of course I can also do that in my head. If I look to find 8s on the other side of the list, I notice that I have an 8 to the 1/3 that's equal to 2. So we're starting to see a connection here. What might be helpful for me is to go back and actually think about the deduction that we made in the previous line. We noticed that if we had a fractional exponent and the denominator of that exponent was 2, that was the same thing as writing something as a square root. And what we might have recalled from a previous lesson is that when we write square roots, there's a little number here called the root index that we don't bother writing in. It's just assumed to be 2. And the reason that is there is because when we evaluate a square root, for example, when we evaluate 81, we're asking ourselves what number multiplied by itself twice gives us 81. And that's why it's a square root, because we're looking at numbers that are squared to give us the value of the radicand. So I'm wondering if you can use that thinking to try to draw some sort of conclusion from how we could rewrite the power 8 to the 1/3. So whatever we have as our base of our power, just like we did with the square roots, we are going to place as the radicand. Notice with the square roots, the denominator of our fractional exponent became our root index of our radical. The same is going to apply when our denominator of our rational exponent is not 2, but is different numbers as well. So since we have an exponent 1/3, then my root index on my radical is going to be 3. So instead of asking myself to evaluate this radical, what number multiplied by itself twice gives me whatever's inside, instead I'm going to ask myself, what number multiplied by itself 3 times gives me the value of the radicand? And in this situation, I would say 2 times 2 is 4, times 2 is 8. So 2 is the number that when multiplied by itself 3 times gives me 8. What you're going to notice is that we could take each of the other fractional exponent powers and rewrite those using radicals as well. So I could rewrite 25 to the 1/3 as the cubed root of 125. I could write 64 to the exponent 1/3 as the cubed root of 64, and so on all the way down the list. What I need to remember as I'm writing out these radicals is that this little number that's up here, that root index, that's a smaller number. And that's not written as a coefficient. That's written kind of in the nook of that root or radical sign. So that's the root index. And then I'll write it a little bit bigger here. That's the number that would be written up there. So this is the learning goal that we are going to be focusing on today, EF1B, and we are going to practice applying the information that you just developed there by evaluating powers with rational exponents. I can also say fractional exponents, and that would mean the same thing. So let's generalize what we just explored on the previous page. We noticed that if we have a power with a fractional exponent, that the denominator of that fractional exponent actually becomes the root index of our radical. Let's now try to evaluate some expressions that involve rational exponents. To do this, I do not want you using your calculator per se. I want you to start by writing each of the powers as a radical. After you've done that, then go ahead and evaluate. Let's start by writing 8 to the 1/3 as a radical. So just like before, I'm going to write in my root sign, and I am going to place the base of my power, the 8, in the place of the radicand. The denominator in my fractional exponent is becoming my root index. So when I'm trying to evaluate this radical, I'm asking myself what number multiplied by itself 3 times gives 8. Thinking it through, I know that that answer is 2. So if I wanted to check my answer, I can always take my answer and raise it to the exponent that was the root index. So if I go 2 cubed, I know that's 2 times 2 times 2, which is 8. So I know that my original question, my evaluation of my radical, was done correctly. So I want you to go ahead and write the other ones, give them a try, and then check back when you've had a chance to apply your thinking. So take a moment to check your answer and to ensure that each of your questions have been done correctly. Before we go on, I want to just consider some other connections we can make to previous work. If I wanted to evaluate the square root of 4, I think we can all understand that that answer would be 2, because 2 multiplied by itself 2 times gives me 4. When we tried to evaluate the square roots of negative numbers, we said that that was not possible in the real number system. So we said that this was a complex number, so it was not a real number. So we weren't able to do that. The reason we weren't able to evaluate the square root of -4 because there are no two numbers that multiplied by themselves would give us -4. So if I had 2 times +2, that gives me a +4, which is clearly not equal to -4. If I chose to use negative 2 times negative 2, that also gives me positive 4. So clearly that's not equal to negative 4. So we said for that reason, we would not be able to evaluate the square root of a negative number. Let's consider something else. Let's consider the cubed root of 27. We would ask ourselves what number multiplied by itself 3 times gives us 27. The answer would be 3, because 3 times 3 is 9 times 3 is 27. Let's see what happens if we're dealing with the cubed root of negative 27. So notice in this situation, my radicand is negative. The difference here is that the root index of this particular radical is not a square root, it's not a 2, it's a 3. So when we're trying to evaluate this, we're asking ourselves what number multiplied by itself 3 times gives us negative 27, and there actually is a number that does that for us, and that is negative 3. What you can consider is if I have negative 3 times negative 3, that's going to give me 9 times a negative 3 again is going to give us negative 27. So I'm wondering if you can work out some sort of thinking that describes when you are allowed to have a radicand that is a negative value. With a little bit of thinking and extension, I'm hopeful that you see that if my root index is an odd number, then I am permitted to have a negative radicand. If my root index is even, so in this case my root index was 2, but if it were 4, if it were 6, any even number here, then I would not be able to have a negative radicand and have it still be a real number. So now that you seem to be pretty proficient with that, I want you to consider the types of questions that you had. What you're going to notice that for each of the fractional exponents that we had listed in the previous examples, the numerator of each fraction was always 1. But that won't always be the case. Instead of having x to the 1 over n, I might actually have a numerator that is not equal to 1. So we need to know how to handle those situations. So I want us to think back to the power of a power rule that we looked at when we developed some exponent laws. We mentioned that if we have two exponents that are separated by a bracket, that our rule tells us that we would multiply those two exponents. We can take this information and work it in the other direction. We can take the power 27 to the 2 over 3 and actually break down or break apart that exponent. Notice we can use the rule from above to write that as 27 to the 1/3 squared. What this means, if we apply what we've learned about fractional exponents, is that we could take our 27 to the 1/3 power, write it as a radical as the cubed root of 27, and notice that the numerator in our fractional exponent, we can just leave it outside as an exponent. We can now evaluate the cubed root of 27, asking ourselves what number multiplied by itself 3 times gives me 27. That answer is 3. We still have the exponent 2, and remember that came from the numerator in our fractional exponent. So now we have 3 squared, which is equal to 9. So we're going to be able to use the power of a power rule, use it kind of in the reverse order that we used it previously, and basically take our powers with our fractional exponents and evaluate them possibly without the use of a calculator. So this is the general form of that particular rule that we've just looked at there. If I've got a power with a fractional exponent, notice that my denominator, regardless of how I want to write this, my denominator will always be the root index. So that will never ever change. The numerator in our fractional exponent we can think about in slightly different ways. I could place the numerator as the exponent outside of the bracket, so I could do this first radical evaluation first and then apply the exponent. Notice I could also put that exponent, that numerator, inside the radical. Either way will work. It's really going to depend what is most convenient for you in terms of evaluating that power. Let's look at this a bit more deeply. Let's start with the first one. We've got 8 to the exponent 2 over 3. Just as before, whatever my base of my power is, the 8, is going to become my radicand. The bottom number, the denominator, is going to become my root index, and my numerator is going to become my exponent. Now, what we said earlier is that I could place the exponent in here, or I could write this as the cubed root of 8 squared. So see that my numerator could become either my exponent, and I could actually write it inside the radical, or I could write it outside the radical. Those are my options. What I would suggest, or at least what works best for me, is keeping my numbers as small as possible, simply because I'm more proficient with the multiplication of smaller numbers than larger numbers. So for that reason, I'm actually going to use this second way to write it, because it's a lot easier for me personally to know what the cubed root of 8 is than to know the cubed root of 64. Now, I might know both in this situation, so might you, but as a general rule of thumb, the smaller numbers work a little bit better. So if I'm trying to evaluate this, I'll ask myself what number multiplied by itself 3 times gives me 8, and that is 2. And now I still have the exponent 2 that was part of my original question. So there's the 2. It's still here. I haven't used that yet. Now I'm going to go ahead and evaluate that power. 2 squared is equal to 4. What I would ask you to do right now is to copy down each of these questions, pause the video, and give each of them a try. You may need to be able to recall your knowledge of negative exponents as well. Something else I want you to be careful of is the placement of brackets in each of these questions, as well as the negative signs that are related to the base. So give these a try. So let's begin by taking a look at question B. First thing I really want to pay attention to is that negative sign that's out front. Now, I always have to ask myself when I see a negative sign like that, is that negative a part of the base of this power? Notice that we have the exponent 5 over 2, a fractional exponent, but because there are not any brackets here, this 5 over 2 only applies what it's directly connected to. So this exponent 5 over 2 is only connected to the 25. That negative sign, we can think about that as being almost out front, and that is not part of the base of the power. So I'm going to write it like this, and if it helps you to see it, really, this is the power that we are dealing with here. Once we establish that that's the case, I can go ahead and try to rewrite my power with the fractional exponent as a radical. Just like before, I'll write in the root sign. I'll have a 25 as the radicand because it's the base of my power. That becomes the radicand. The denominator of my fraction becomes the root index. So if I wanted to, I could write the little 2 in here. We often won't see that, as you know. Often, we will just simply write that as the square root of 25, and our numerator in our fractional exponent actually becomes our power. So that's how we would rewrite that power with the fractional exponent using radical form. So now we can go ahead and we can evaluate that. So we'll have negative 5 to the 5. If I wanted to go ahead and keep those brackets in, I could. I just need to remember that still the negative is not part of that base. So our answer will end up being negative 3,125. Let's compare and contrast that to part C. What we're going to notice in part C is that we do have brackets around the negative 32. That means that the negative sign and the 32, so negative 32 is actually the base here. So we need to remember that that base does form the radicand of our next step. So it's the root negative 32 that's inside the root. Our denominator becomes our root index, and our numerator becomes our power. So we'll notice that this is an example where our radicand is a negative value. When we examine our radical more closely, we see that the root index is an odd number, so we know that we're still going to be able to generate a real answer. We're asking ourselves, in order to evaluate this radical, what number multiplied by itself 5 times is going to give us 32. I know that if I multiply 2 by itself 5 times, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, then I'll get 32, but I want to get negative 32. So instead of multiplying 2 by itself 5 times, if I multiply negative 2 by itself 5 times, will give me negative 32. So the answer to the fifth root of negative 32 is 2. I'm going to copy down the exponent that I have there that came from the numerator of my fractional exponent, and now I'll evaluate that power. Negative 2 times negative 2 is positive 4, times negative 2 is negative 8. Let's take a look at the last one. I'll notice here that I have a negative exponent in addition to having a fractional exponent. So I think I want to manage that negative exponent first. So I'm going to rewrite this as 1 over 81 to the 3 over 4. And now I'm going to rewrite that power with the fractional exponent as a radical. So 1 over, I know that 81 goes as my radicand. My denominator becomes my root index, and my numerator becomes my exponent. Oops, I've made a mistake there. I wrote that as 84 when of course it's actually 81. So let's start by evaluating the fourth root of 81, asking myself what number multiplied by itself 4 times gives me 81. The answer to that is 3. I need to write the little cubed in there, simply because that was still part of that power as it was rewritten, and then the answer is going to become 1 over 27. Let's examine one last example. I'm asked to simplify this expression. So I could go right ahead and rewrite each of these as radicals. What I will notice, however, is that each of the bases of the powers are the same. So what might be a bit more efficient for us is to apply our rules for combining powers before we actually go and try to evaluate and write as radicals. So I'm going to rewrite my numerator as it is, 5 to the 1/4, and I notice that in my denominator I am multiplying powers that have the same base. Whenever we do that, we are able to add our exponents. So our new power, our new exponent rather, is going to be 1/3 plus 3/4. So just for the sake of efficiency, I've done the addition of our fractional exponents over here, finding a common denominator to begin. So I could rewrite this as 5 to the 1 over 4 over 5 to the 13 over 12. Now I have a situation where I am dividing two powers with the same base. Whenever we're doing that, we can subtract the exponents. So I'll have 5 to the 1/4 minus 13 over 12. And now let's do that subtraction as well. That means that this could be written as 5 to the negative 10 over 12. We never really want to leave our answers so that they have a negative exponent, so I would definitely want to rewrite that. Before I do that, notice I can actually simplify that exponent by reducing the fraction that's there, so I could rewrite that as negative 5 over 6. I could then rewrite this as 1 over 5 to the 5 over 6. And continuing to write that as a radical, I could rewrite that as 1 over the 6th root of 5 to the 5. I could also evaluate that and apply that exponent 5. We are going to notice, though, that that's not going to be a nice round number. That's definitely going to be a decimal. So our answer could be provided using 1 over 5 to the 5 over 6. Sometimes it's just asking you to write it so that they're positive exponents. If they're asking for integer exponents, then I would need to proceed and write this as a radical as well. So there's a little bit of checking your understanding work that you're going to try from the textbook to see whether or not you've grasped this concept very effectively. So give that a try now.